Welcome back to Practical PyTorch. Last time you learned to tell learning from memorizing. Now the run that will not even start or trains and does nothing. This is debugging, shapes, devices, and gradients. A lot of what trips up beginners comes down to three errors: a shape mismatch, a device mismatch, and a grad that comes back none. The first two raise an error you read in a traceback. The third is silent. No traceback. You inspect the tensor instead. Every one is diagnosable. For the two that raise, read the traceback bottom up. The last line names the error. For the silent grad bug, you inspect the tensor. Then run the same triage on each. Symptom, likely cause, and the one line that fixes it. This video has 4 parts. First, read the traceback bottom up. The last line names the error. Second, the shape mismatch. Print the shapes, then assert them. Third, the device mismatch. Move one tensor to match. And fourth, when grad is none. 4 causes and 4 one-line fixes. First, the reading habit. A traceback can be long, but only one line names the error. A traceback is printed top down, but you read it bottom up. Skip the stack of frames. Jump to the last line. Here it says, runtime error, mat1 and mat2 shapes cannot be multiplied 3 by 4 and 3 by 4. The frames above trace how you got there. The last line names what broke. It carries the error type in the message. Read it first every time. Now the first family. 2 shapes that do not line up for the operation you asked for. You will run this same triage 3 times. Red is the symptom you read off the traceback. The shapes cannot be multiplied. The arrow leads to the cause in gray. The inner dimensions differ. 3 by 4 and 3 by 4, and 4 is not 3. Green is the one line that fixes it. Print the shapes, assert the rule, then reshape to match. 2 tensors, both shape 3 by 4, matrix multiplied with the @ sign. A matmul needs the inner dimensions to match, and 4 is not 3. So it raises. Runtime error, mat1 and mat2 shapes cannot be multiplied 3 by 4 and 3 by 4. The message prints both shapes. That is the whole diagnosis. This is the shapes lesson coming back as an error. Do not guess. Print each tensor's shape right before the failing line. Both come back torch dot size 3, 4. Now you can see the 2 shapes. Once you know the rule, assert it. Assert that A's last axis equals B's first axis. Now the error names itself at your own line. Print shape is the fastest debugger in PyTorch. Now the second family. 2 tensors that live on different devices. Same triage, new family. The symptom in red. A device mismatch, 2 devices found. The cause in gray. 1 tensor is on the accelerator and 1 is still on the CPU. The fix in green. Move 1 to match with dot 2. This is the dot to lesson coming back. 1 tensor made on the CPU by default. 1 made on MPS, the accelerator. Add them together and the operation cannot span 2 devices. So it raises. Expected all tensors to be on the same device, but found MPS 0 and CPU. The message names both devices. On an NVIDIA box, the same line reads CUDA 0 and CPU. Same error, different device name. Pick 1 device and put every tensor there. Move the stray one with dot 2. Here, x equals x dot to MPS. Now both are on MPS. The rule is 1 device for the whole computation. Move your inputs in your model there once. Watch out. A new tensor usually starts on the CPU unless you set its device. A stray CPU tensor is the usual culprit. Now the third family and the silent one. You reach for grad and it is none. Same triage one more time. The symptom in red. Grad is none. No gradient was stored. Careful, none is not a zero gradient. Zero would be a real computed value. It was never computed or it was cleared away. The cause in gray. It was never computed or it was cleared. This time the fix is a checklist in green. 4 causes, so match the cause to its fix. Cause A you forgot requires grad, so nothing was recorded. Grad comes back none. Check W dot requires grad. The fix, set requires grad to true. Cause B requires grad is on, but you never called backward. So grad is still none. Check that you called backward. Then it holds 3.0, the slope of 3W. Cause C you detached the tensor, so it left the graph. Now requires grad is false. Check you did not detach what you train. The fix, don't detach it. Those 3 are the auto grad lesson. Cause D you called 0 grad after backward, and that wiped the gradient. It was 3.0, and now it is none. Check that 0 grad runs before backward. That is the loop lesson next. 0 grad clears gradients. Call it after backward, and you erase the gradient you just computed. Backward fills W dot grad with 3.0. Then 0 grad wipes it before the optimizer sees it. 0 grad belongs before backward, not after. The order the loop teaches. 0 grad backward step. And here is the trap. Opt.step skips any parameter whose grad is none, so it never updates and nothing errors out. Let's bring it together. Read the traceback bottom up. The last line names the error type in the problem. Shape-mismatch. The message prints both shapes. Print them, assert the rule, reshape to match. Device-mismatch. The message names both devices. Move the stray tensor with dot 2. And grad is none. Check requires grad, check you called backward, no stray detach, and 0 grad before backward. One check before we go. A 30-line traceback fills the screen. Which line do you read first? Pause and predict. The answer is the last line. Read bottom up. The frames above are only the path that got you there. The final line carries the error type and the message that names the bug. Read it first every time. You can now read the 3 errors that cost the most time. But once it finally trains, how do you keep it? The next lesson is save, load, and use a model. How the trained weights survive the process that made them, so you can load them back and predict on one new sample. See you there.